Greetings, everyone. Welcome to eStudy Box, digital education platform of nearest university. Today's webinar is about beekeeping and technologies, and our speakers will discuss the practice of beekeeping as well, how AI technology will impact the future. I would like to introduce our speakers, Professor Dr. Salih Gücel from the Faculty of Agriculture, Professor Dr. Fadi Al Tujman from the Faculty of Engineering, Professor Dr. Özge Özden from the Faculty of Agriculture, and Dr. İlker Gelişen from the Faculty of Pharmacy. Dear audience, I would firstly like to invite our first speaker, and I will briefly introduce him. Professor Salih Gücel is a biologist specialized in botany plant ecology. He works at the Environmental Research Center and he is the Vice Dean of the Agriculture Faculty at Nearest University. He has been involved in ecological research, conservation, and awareness raising for more than 25 years in Turkey, Egypt, Pakistan, Turkmenistan, and Cyprus. Since 2005, he is also involved in bio-communal work. Dr. Salih, over to you.
Welcome, everyone. The audience. I would like to give you basic information about why beekeeping is important and why we need to apply technology. Uh, I uh, I work at the nearest university environmental research center and faculty of agriculture. That's why we decided to set up a program to introduce new technologies in beekeeping. So, beekeeping is an activity that is made for several products. The best known is honey, but there are several other things that has properties with like antiviral properties, anti-cancer properties, antibacterial and antiparasitic properties. Also, uh, they are good apart from the health issues. It's a good product for breakfast in many cultures, but it's a well-known honey is a well-known product for many other things. So this is why people like to have to grow beekeeping. It's an agricultural process activity, but when it comes to the nature of honeybees, there are so many subspecies uh, distributed in the world. And in Cyprus, there is a well-known subspecies Apis mellifera, subspecies Cypria. We have this honeybee, local native honeybee, and for this reason, the beekeeping is a well-known and story activity in Cyprus too. So this made us to concentrate on this issue and to make beekeeping and production more profitable, more benefitable. So we started collecting data from the statistical books or other compiled data. And so we had an idea about the hive counts since 1984. We can see the trend in uh, this beehive count, this trend in hive differences. We also counted honey production, and so we understand then there is a need to obtain more precise data for future estimations. When we are talking about the productivity, I mean the mm, the most the most expected outcome is the product. So everyone is interested in the product. So that's and it's because of the economic activity. That's what makes people to be motivated to do beekeeping. But when it comes to the product, I mean, it starts from the beginning. It starts from the bee. So this is why we need to have observe the bees and to have the best active and best productive bee, best suitable bee for our country. And then it comes to hives. The hives are important. It keeps the colony inside, but and we have to know what is changing in the bee in the hive environment. So this is why these are the two things that we can control. So the bee and that's and the bees will be produced or will be or they will be checked by agricultural mm, ag- uh, agricultural practices, but the bee and the hive and the colony should be checked by the beekeeper. But this needs time and more programmed uh, program visits. So with the technology, we want to check the hives uh, all day, and we want to use and this is why the AI technology, sensors, smart technologies are important to check to get this data all through the all through the day and the week and the months, and also the data that we will get from this uh, technology, then we are going to use it for scientific research. So this is why it's important. And the third component that we cannot control is the nature. There are diseases, there are climate change, droughts, there are agricultural poisons, mites, hornets, and we don't know that we cannot control the drought or temperature. So that this is why we have to make sure that at the first two stages we need to we have to do the best of we can do, and let the nature let the bees to go into this harsh nature. So this is what I wanted to explain you, give a brief description, what I wanted to, what our aim is to say. And I would like to tell you a good webinar. So thank you for everyone.
Thank you very much. I would like to invite our next speaker, and I will introduce her. Professor Dr. Özge Özden was born 1st October in 1977 in Nicosia. She completed her secondary and high school education in Lapta Yavuzlar High School in 1994. Then, after graduation from Uludağ University from Faculty of Architecture, Department of Plant Protection in 1999, she started to work as a research assistant at European University of Lefke Faculty of Agricultural Science, Department of Horticulture in 2000. In the same year, she started her graduate education at Çukurova University, Faculty of Agriculture, and received the title of Agricultural Engineering in February 2002. Between 2004 and 5, she worked as a scientific research project with Bonn University in Germany as a one-year full scholarship. Özge Özden completed her doctorate uh, in Department of Biological Science at University of Exeter in England in 2009 and received the title of doctor. In 2010, she has been also visiting research fellow at University of Exeter since 2009. Professor Dr. Özge Özden has been working as a lecturer Department of Landscape Agriculture since 2012. She has many scientific articles published in international journals, 46 papers presented at international conference, and 4 books published separately. There were 27 scientific research projects in total that have received international support EU, UNDP, FG, BMZ. She is currently professor of ecology at nearest university and has been working as the deputy director of nearest university Cyprus Herbarium and Natural Historical Museum since May 2019. Additionally, she was appointed as the founding dean of Faculty of Agriculture in September 2021. Yes, Dr. Özge, over to you.
Morning, everyone. Welcome to our seminar. Today, I would like to give you a lecture about bees of Cyprus. So, history of beekeeping in Cyprus, existing on the island for thousands of years. And even the ancient Cypriots were known for their honey production and trade. Here, I would like to show you about clay beehives. These were the traditional beehives that Cypriot beekeepers used to use on the island. And when we look at the written testimonies, they also refer to Cyprus as a honey producer since ancient times. When we look at this historical part, it goes up to ancient Greek and Roman period. Here you can see horizontal clay beehives on a house of a roof in Larnaca. We found this literature from 1882 that people used to keep bees on their house roofs. And this is an example from the village called Kalavaç. It's between Nicosia and Famagusta region, a traditional Turkish Cypriot village. This photo has been taken by Professor Salih Gücel last week. As you can see, the clay hive still existing in the village, but unfortunately, the young generation not using this type of hives anymore. And when we look at our island's climate and landscape, we can see in springtime a very high number of flowering plants, and it is a very good source for pollinators. So we are really lucky to have such a, diverse landscapes, particularly in our country, Northern Cyprus. These are some of the examples that I can show you as a flowering vegetation. You can see Thymus capitatus as a shrub, a very good source for honeybees. And the right side, you can see Salvia fruticosa, local sage. And the bottom, you can see Cistus criticus, also a very important nectar source for many type of bees. So when we look at the literature, we have seen that Cyprus hosting very widespread bee families. These are the families that we can find on the islands. And the Apidae family, which is representing around 110 species, is the largest family of the bees, and honeybees are under this family. Currently, many research going on, and every day we discover new species, new records on the islands. We have a collaboration with Wageningen University, another university in Netherlands, together regarding pollinators. And also in the previous years, I had a research project with Exeter University and with some PhD students. So we added some numbers already to the number of species existing from these families. And what we need to say here, bees are very important for Earth because without them, the whole ecosystem would collapse. So bees are vital for pollinate the food and for our survival, and also pollinating many wildflowers and trees and providing habitats for the wildlife. So we should consider bees part of our life part. So we also looked at the honey production on the island, and we always check what is the situation with the Greek side. And the southern part of the island, we have seen that around 6,000 registered beekeepers existing, and they are getting annually 600 ton honey per year. And when we look at TRNC, we learned that there are around 359 beekeepers registered to the veterinary department. And there is a discussions about how much honey we have between the beekeepers, also the local authorities. There is no clear amount of honey yet that we can define it. So one of the reasons we would like to do intensive research in our country to be able to know the trends, what we have, the hive population, the amount of honey we producing, etc. And also, as Professor Salih Gücel mentioned, we have so many diseases and pests that's harmful to our bees. And I try to summarize these diseases and pests on this table. We have parasitic mites, and everybody, all the beekeepers know about varroa, but we also have Acarapis woodi. We have some protozoa that causing diseases on the bees. Uh, Many beekeepers know only nosema, but we may have also Malpighiopea or Monoica apis, for example. So we need to do really intensive and proper research about this, because we know and we observe many deaths of the honeybees from different regions. We have some fungal diseases. Just last week, we found in one of the beekeepers' farm. These are the things that existing in the world: Ascocephera, Apis, and Aspergillus species. And we have some bacteria, Bacillus species. For example, we use Bacillus ingredient for pine processionary caterpillar control. And when we found out that Bacillus spores, if they reach to the bees and touch their skins, they are very harmful and they may kill the bees within 6 days. And also other bacteria, Streptococcus and Pseudomonas species. And we have viruses, paralysis viruses, black queen cell virus, deformed wing virus, Israeli acute paralysis virus. There are some research going on, I will show you later, in the world. But we just recently this year visited Italian Research Institute in Napoli with Professor Gugel, and we bring some samples, and they are currently doing ELISA test to be able to say which virus we have. But when we look at the behavior of the bees, already we have seen some paralysis virus syndromes, and also I noticed on my own bees deformed winged virus symptoms. So, but we need to prove this in the laboratories. So we already started initiative, and we will carry on to do more intensive research and sampling in our country. And also we have other insects like hornets or some moths. Like last year, I lost two of my hives. One was the secondary pest was moths, and I have seen them. And other animals like bee eaters, geckos, and some other lizards. So later on, Professor Fadi and Assistant Professor Ilker will present you about new technologies that we can observe all these things. We can have automatic alert systems with the hives and with our just mobiles. So we will be able to do observation on time, and so we can prevent these things effectively. So when we look at the research, very few research carried out in our country. This was one of the things I found, carried out by Irfan Kandemir. And I have seen that many research carried out, particularly in USA and Australia, regarding behavior ecology of honeybees, but there isn't any other research, not only in TRNC, on the island, regarding behavior ecology of the honeybees. I only found one paper that published by some French scientists, actually, carried out research in Cyprus regarding Cyprian honeybee colonies under attack from the hornets. Very good paper that was. And me myself, I feel embarrassed as a Turkish Cypriot scientists that why we cannot do such a research. So we will. We are really targeted onto this. And here I put you some photos relating to honeybees virus diseases. Here on the C, you can see the deformed wing virus, and also in the D, you see bee paralysis virus. This is typical, the bees coming out of the hive and on the ground they are just walking, scrolling, and they cannot fly, and after few days they die, unfortunately. And also I found this research which was carried out in Italy in 2013. It was the first isolation of Kashmir bee virus, which was introduced to Italy. Because of what we have found with Exeter University research, we found that some of the wild bees are migrating, and we proved that with our research. So some of the viruses are not only on honeybees, they are on other type of wild bees, and it can be carried from country to country due to climate change. And another just recent in 2011, they found the Israeli acute paralysis virus in Italy. So you can see the movement of the disease from one country to another country, because this Israeli acute paralysis virus first found in Israel in 2004, and then it moved to Italy and they published it in 2011. So not only we need to start to carry out our research, we need to do continuous research to be able to follow up all the diseases and viruses. So our targets, we work as a scientific team, and I am so happy about this collaboration with different faculties. So I would like to thank Professor Fadi and Professor İlker Hoca that they are supporting us as a Faculty of Agriculture, and really happy to collaborate with them. So one of the things we would like to carry out genetic barcoding and taxonomy research. We already started with Dr. Gennaro from Italian Research Institute, and hopefully this year we will do more sampling, and using smart technologies for behavior ecology research that we will collaborate with our colleagues. Identification of Cyprus native nectar sources, plant species, and their interaction with honey aroma. And this we will carry out more with Professor Gücel and do more sampling about this. And diagnosis of bee diseases or bee pests. And this is my main target. So I need to do many dead sampling of dead bees, and also honey quality characterization studies that we would like to carry out with our food engineering department academics and also Italian Research Institute academics. So thank you very much for attending to our webinar.
Very much, Dr. Özge. It was a delightful and informative presentation. I would like to invite now our next speaker, and I will also introduce him. Dr. Mehmet İlker Gelişen, graduate from Hacettepe University Faculty of Medicine, specialized in anesthesiology and intensive care in Germany, worked 3 decades in Turkish pharmaceutical industry and teaching basic medical science in nearest university. Special interests are artificial intelligence and healthcare. Dr. İlker, it's over to you.
Good morning. After hearing more about the bees and beehives, let me add a couple of information about the technologies we are using to much of our ecosystem depends on the pollinators such as bees. The bee population is declining actually. But with the help of the technology, such as artificial intelligence and Internet of Things, we hope we can help us to reverse that trend and also help us to get the business more profitable. What do we need to monitor or why do we need to monitor? First of all, the beekeepers use or used to examine the hives physically and try to understand what is happening or try to catch the things before they happen. All those physical examinations may not be successful or may have problems of late detection of temperature and moisture changes in the beehive, in and outside of the beehives, presence of diseases and parasites, and also the changes in the hive as preparation of swarming. Therefore, visualizing every hive every minute and receive early indications of what's happening inside and outside will keep the beekeeper to plan and manage visits, workforce, and the time to keep the eyes on what really matters in the beehive and around. To do it so, we actually need sensors. We have devices. A lot of devices have been discovered or prepared, and they are composed of set of IoT sensors. They can be placed inside the beehive or outside the beehive to monitor the changes inside and outside. When these sensors we can monitor with those sensors we can actually monitor the humidity, temperature, sound, and motions of the bees inside and outside of the beehives. Bees do their best to keep the hive in optimal conditions, often swarm due to the inadequate ventilation or high temperatures. So having live data on humidity, temperature, and also weight of the hives will give us information about the climate in the beehive and also the amount of honey which is being produced or which has been produced in the beehive. That is controlling the weight variation of the beehive. And also, when we have all those sensors, we know where the beehives are. We can check their locations. I mean, thieves are all around, and we will be safe by checking the location of our beehives. Those sensors can be microphones, cameras, and with the help of those sensors, we can see invasive predators and capture live data from the bees and hives. As I kept seeing up to now, temperature, humidity, acoustic data, bee density, activities, and the flight patterns of the bees, hive weight are very important. For example, when the temperature inside the hive is increased, the bees start flying inside the hive to get the temperature lower. When the humidity is low, they bring water to increase the humidity inside the beehive. The acoustic data we are getting, or we may get with the help of our sensors, with the help of our microphones, will help us to understand what is being done inside the hive. For example, when the bees find out or discover a new area which has good flowers and worth to visit, when they come to the beehive, they start dancing. and that dance tells the other bees where the flowers are, how far is it, and how they can fly to that. We can get most of those informations, almost all those informations, when you continue looking at our data from our cellular phones, from our laptops, wherever we have them, and connected to the beehives where we have our bees. The next ones are actually the things which will be told soon. With, I want to thank to the beehive monitoring systems, which gives us the opportunity to recognize what is the weight gain of the honey, production of honey in the beehive, what is the reduction of supplies, if something is unusual happening that needs attention, when the beekeeper needs to attend to the beehives and when it is not necessary, how the temperature and the humidity in the hives are developing, how the bees are buzzing, if the bees are stressed, how the situation in the hives change in the whole period of using those sensors. Those are the things I actually want to summarize. They are all very important data for us. And now the next presentation will be talking about how to do it technically. Thank you very much listening to me. Have a nice day.
Thank you very much, Doctor. And dear audience, I would like to invite our last speaker in this webinar. Dr. Fadi Al-Turjman received his PhD in computer science from Queen's University, Canada in 2011. He is the advisor to the chairman of the Board of Trustees of AI and Informatics at the nearest university, Nicosia, Cyprus, and the associate dean for research at the Faculty of Engineering in the same university. Professor Al-Turjman is the head of Artificial Intelligence Engineering Department and a leading authorities in the areas of uh, smart intelligent load system, wireless and mobile networks, agricultures, protocols, deployments, and performance evaluation in artificial intelligence of things. He is the founding director of International Research Center of AI and uh, uh, AOT and the AI of Robotics Institute at Nias University. His publication history spans over 500 CCI publications, in addition to numerous keynotes and plenary talks at flagship venues. He has authored and edited more than 50 books about cognition, security, and wireless sensor networks deployment in smart EOT environments, which have been published by well well-reputed publishers such as Tyler and Francis Elsevier's EAT and Springer. He has received several recognition and Best Research Awards at key international venues. Professor Al Trujman has led a number of international conferences and workshops in flagship AI and AOT societies. Currently, he serves as book series editor and lead guest editor for several top-tier journals, including the EAA Communication Surveys and Tutorials, and the Elsevier Sustainable Citizen Society, in addition to organizing international conference and symposium on the most up-to-date research topic in AI and AOT. Yes, Dr. Fadi, it's over to you.
To share my screen also shortly, where we have couple slides. Yes, entire screen. Yes. Hello, everybody. So I am going to share a few thoughts actually about the technology and the beehive monitoring in the era of Internet of Things and the artificial intelligence revolution that we are experiencing nowadays. Before I start, this is me, Professor Dr. Fadi Al Turjman from Computer Science field, and thanks for the nice introduction. It will be a pleasure to start my talk by mentioning again the main title or topic that we are interested about today, which is behave monitoring technologies. Before I start, I would like to take also this opportunity and talk a little bit about the institute that I'm directing right now, which is the AI and Robotics Institute in Near East University, where we have several similar projects that has been discussed so far today in agriculture in general and smart environments as well to realize these kind of intelligent solutions that relies on sensors and artificial intelligence. And this institute, by the way, is adhering to the 17 goals that has been recently announced by the UN, and we are applying them in our ongoing projects. I will give you an idea about these projects so that we can start warming up, and then I will go a little bit deeper into the behaving and keepers technologies. So, in general, as I said, we are working in the area of smart environments to realize smart spaces around us and enhance our decision makers life by giving the intelligent solution into their hands. I will give a few examples, as I said, for the project that the institute was working on or was involved in the last few years. The first one was an underground actually contamination issues where we were monitoring the soil in the fields in agriculture to predict or even detect sometimes contamination and protect the plants and the farms from any side effects that can affect the farm production or productivity. So that project was mainly relying on a chain of sensors that can be deployed under the soil in the farm, for example, with a transceiver that is connected directly to a base station at the laboratory where the specialist can watch continuously the status, for example, of that soil, how much healthy it is, and if there is any kind of contamination flow, directly it start an alarm system that will make people in charge to take an action. Another application was the rice field monitoring application, where we also were interested in providing the best quality of water for the rice fields to assure the quality of the rice produced from that farm. And we were relying again on sensors that can be deployed under the ground and continuously monitor the status of the rice field via wireless communication towards the laboratory or the headquarter of the company that is managing this actually business. The main idea here was watching and monitoring the soil moisture, the pressure under the soil, and the water quality that has been fed into the farm, for example, during the season of that rice production. Another project that I consider personally one of the interesting projects that I worked in the agriculture field was the smart turtle or a smart system in detecting turtles or species at risk, especially from turtles. So there was a little problem in one of the regions, actually specific regions in Canada, where the special types of turtle were disappearing or they are starting to disappear in the nature, and the ministry was interested to learn the reason to protect this specific type actually. And to do this, we developed a small box that can be attached to the shell of the turtle and keep monitoring the turtles during their life cycle. And luckily, we were able to detect that at specific season where they have to pass from one region to another through a river, they are losing huge numbers of their species. So these numbers was disappearing simply because there was a very cold water in that river in that specific region that kills the turtles and makes them unable to reach to the other side. This was luckily determined and detected using our smart small box that was attached to the shell to monitor the temperature, the humidity, the pressure that the turtle is facing during his life cycle. And we were delivering this information again wirelessly through satellite communication system to the end user who was able to monitor and process this data. Finally, the last example I wanted to share also regarding the agriculture was the example where we used these sensors or wireless sensor networks in monitoring the forestry fire. And we were able to prevent these kind of accidents before it happened by just monitoring the temperature sometime in these regions that have frequent fires, for example, or similar accident during the year, and provide the necessary help or service to that region before the damage becomes bigger and we lose large number of the green areas. So wireless sensor networks in these cases were very successful and very effective in monitoring and preventing such kind of accident by just watching the temperature, the humidity level in this region, and deliver this information via a multi-hop network to the base station where we can provide kind of or an alarm if something unusual is going to happen. The most related part is coming now, where we are working in the institute on smart boxes. These smart boxes are enabling the smart environments that we were talking about by simply plugging in these smart boxes to the environment that you want to monitor and you want to make it smart, which can be the beehives in this case or in our case. What these smart boxes consist of, it's mainly consisting of a microprocessor which comes in a off-the-shelf board, for example, such as the Raspberry Pi or Arduino board, in addition to a set of sensors that can be attached to this board to monitor the temperature, the humidity, the pressure, the light intensity, the sound, for example, and so on. So it enabled multi-sensor connections. It enabled the wireless communication via Wi-Fi, Bluetooth, infrared, and sometimes wired connection or satellite connection as well. In addition to having multiple relays that can enable connecting to these tiny processors as much as you want appliances and sockets or energy sources. And then we have, of course, the interface that has graphical user interface to be displayed for the end user, either on his smartphone or on his desktop or PC that he is using to monitor the application via this smart box that we attach to that environment. I have couple videos here that shows how these kind of boxes have been developed in our center here. Let me share the first one with you. This one shows simply how we control the lights, for example, manually using a
and they are
mobile
connected
application.
Raspberry Pi and the relay, and we will give the instruction in our mobile. A few two lamps representing two rooms, and they are connected Raspberry Pi and the relay, and we will give the instruction in our mobile. In room 2, let's switch our room 2 lamp. It's switch on, see, and let's do the room 1 light on. It's going to be on.
So here it
Let's
shows how
switch
we
on
can
both of
switch
them,
on and
both
lights, on and
rooms.
off the lights, for example, using just a
Let's
press
switch
on
off,
the mobile
and the other
application.
hand, switch off, switch off.
The next video, it shows how we can control this
Then
on and off process
at
using
45,
pre-scheduled
lamp
actually
switch off.
timer.
We said switch on at 1, so at 45, that lamp will be on automatically. Yes, see, at
As you can see,
45, the
at that
lamp
specific
became
time,
on.
we can also turn off on the light or any other attached appliance. Also,
We
we
are
can
going to
control the
demonstrate
temperature of the room via
smart
heaters.
infrastructure by controlling the heater from our mobile. Heater now is off. As you can see, the heater is off. So we're gonna on using our own mobile. Let's give the instruction for on, and then we give the instruction as you see, and then the heater is coming on. So I'm going to switch off by using the same method using the mobile. Just this, as you see, is the heater. Let me just say off, and then the heater is going to be off. Other appliances like the lights.
So same applies to any appliance that you attach to this smart box to control it and to provide kind of an alarm to make an action or keep an interaction with the system that can be caused by an animal attacking the beehive, for example, or a thief who is trying to steal the beehive, or a forestry fire that can start and can affect your bees. All these can be monitored simply by this smart application and smart box that will be attached to the hive of the bees and will be 24 hours, 7 days monitored via the specialist people. So the general system architecture that we are talking about here can include a box, smart box we call it, attached to the hive, and this smart box can be powered using different methods. Can be powered via the wall electricity, the main supply, or it can be powered using renewable energy such as solar panel, wind energy, and vibration energy, and so on. And these also boxes comes with different sensors that can monitor the environmental factors that affect the bees and their productivity, as Dr. Ilkar mentioned. And it is also coming with different communication technologies, can be wired and can be wireless, Wi-Fi, RF, for example, or infrared technology, satellite, wireless communication. All these are possible methods to communicate with the hives through that smart box. And the data that is collected via this wireless communication or wired communication method will be transferred to the cloud, to the internet, and will be analyzed there through data mining processes and capable servers that can make huge processes or perform huge processes in very short time and analyze the situation and provide the expert or the farmer an idea what he should do next or if there is an action to do or not to improve the quality of the honey or the productivity of the bees in that cell. So that's simply the system architecture that we are talking about. As I said, it comes with several sensors, depends on what type of information you want to monitor, you want to watch in these hives. We can install ultrasound sensor, we can install motion sensor, we can install temperature sensor, humidity sensor, GPS to localize these hives wherever they go. We can install as much as you want sensors to provide the targeted information that can improve the productivity and the safety of the hives while we are producing the honey. So that's simply what I wanted to share with. In addition, of course, to my final thoughts regarding Professor Dux that you might heard about it also recently. Professor Dux is going to help a lot in such applications. He is able to discuss with the farmers, with the beekeepers, the best methodologies to follow the strategies while they are growing the bees and their productivity, how to be optimized. He will be chatting with the farmers. He will be providing solutions and alternatives in case the farmer is not sure what to do. It comes in different platforms. The farmer can socialize with ducks right now through his Facebook account, for example, or WhatsApp account. He has the platform where he can upload some data, for example, to Professor Dux, and Professor Dux can analyze it for the farmer and provide him a summary about it or a suggested solution in case if it was a problem, for example. I wish this was an informative short session about the technologies that we can use, of course, in this area. And if you have any question, I will be happy, of course, to receive your questions through my email, which is fadi.alturjman@neo.edu.tr. And I will be happy to provide you answers via my email in case I receive any question. Thank you very much again and wish you a happy weekend. Thank you.
Thank you, Dr. Fadi, and I would like to thank our all speakers. Dear audience, today's webinar was about beekeeping and technologies. Thank you for your attention.